Hello everyone. Today is February 12th, 2019. My name is Thomas Kim. This is my first episode about C++ type functions and modern C++ programming. This is for motivation for new series of type functions. I will talk about good design and bad design in C++ programming. Please click this link to download type library. We will use this file very soon. C++ standard template library including std vector, std deque, std set, std map, etc. with some algorithms were introduced to C++ 98 standard for the first time in C++ history. Then std tuple was introduced to C++ 11 standard, and std variant, std any were introduced to C++ 17 standard. Also, constexpr, auto L-value reference, auto generic reference, and perfect forwarding or universal forwarding or universal reference, decl type, lambda were introduced to C++ 11 standard. decl type auto was introduced to C++ 14 standard. If constexpr was introduced to C++ 17, and the concept will be introduced to C++ 20 standard. Concept in C++ 20 standard in action. In this video about generic template metaprogramming, in this video I explained what is concept in C++ 20 standard, and I got 3 thumb downs. You can learn what is concept in C++ 20 standard, how to use it, why it is important, things like that. In this session, I will explain what is good design and what is bad design, why we need to understand type functions. Without understanding C++ type functions, we cannot use these advanced C++ constructs in modern C++ programming. std tuple, std variant, std any. Without having solid understanding about type function, we cannot take full advantage of these advanced libraries of C++ template class. Please unzip the file. If you open the file, I opened with Notepad. This file is rather big. It's about 2,600 lines of code. So it's a little bit complicated, but I believe this library is good design. I mean, this type library I developed is good design. I first wrote this application in January 17 of this year. Today is February 12, almost 25 days I haven't used this library, or I haven't talked about this. I was a little bit hesitating about disclosing this library because I haven't thoroughly tested this library yet, but I want to give some motivations why we need this kind of advanced type functions and type programming. I will show you another library that I created by myself. This is a library I developed the day before yesterday, February 10. This file is rather short, much shorter, 881 lines of code, but this is bad design. The integral part of this library is this function, this beast each permutation function. This is a single function, is pretty long and pretty complicated. So this is a failure. The reason this library is a failure is that this function plays the integral role, most important role in this library. However, this function is very complicated and very big. This is a single function, is such big. But in type library, Most functions are very short and manageable. Good design in C++ is an extensible, scales well in future development. Bad design in C++ is not extensible, does not scale well, does not combinable with other libraries. So this library is rather manageable, maintainable. But this for each algorithm library is unmanageable, does not scale well, and very complex. Both of these two libraries are my own class, my own libraries. In this case, for each algorithm, I failed. What I mean by failed is that not because this function does not work properly or this algorithm does not work properly. This function and algorithm works perfectly without error, without bug, but it is not manageable. It does not scale well. It is not extensible for future development. In that sense, I'm saying this library is a failure. So when you develop a library, you have to consider future development and scalability and manageability. If your library is not scalable and not manageable, then that is a failure. So good design in C++ is extensible and scalable for future development. Bad design in C++ is not extensible, not scalable, not combinable with other libraries. When I designed this library, type library, I designed it carefully. At each step of developing this library, I considered future development. But when I developed this library, this for each library, I have not thought about future extendability or scalability. Though it works perfectly with optimization, it is not manageable. The program becomes too much complicated, so it is a failure. When we design our software, we always have to think extensibility, scalability, and combinability with other libraries. Okay, let's get started. If you haven't downloaded my library yet, please click this link to download. In the download folder, copy this file and paste it to your working directory. I will create a folder here, type function tutorials. Double click this folder, create another folder, include, and in this folder paste the file, and in type function tutorial copy the folder path. Then in your command prompt right click once again, properties, in starting path Ctrl A, Ctrl V, then click OK. When you double click the prompt, your starting path should be your working folder, type function tutorial. Start Visual Studio Code, file, open folder, paste in the folder path, select the folder. In the type function, we will create a folder 01 motivation. Enter, and in this folder create a file stream cpp. This is our first session, so I will let you know how to use new stream library that I created by myself. And all future sessions, I will use this stream library, include to include talk play fun type lib type util. This library will be the first include. It includes most of the files. So int main. First, we need to have auto stream talk play fun stream. This is a function. Then we need another object like this, nl. nl means new line stream get console out like this. Then we can print out text like this, stream hello type functions. Then we can put nl like this. We will build this library and test it. In the command prompt cd o1 motivation stream cpp. This is the file. We will compile with this Microsoft compiler first, ehsc. We need std C++17 library stream cpp fe mexe. We are compiling with Microsoft compiler, and you should build successfully like this. Okay, hello type functions. Now we are compiling with GNU compiler G++, std C++17 stream cpp o gexe. GNU compiler should also work G like this. Now I will explain some basics how to use this stream library. I will declare a vector like this using vector t std vector int. I declared a vector like this, vector t ins. Ins means integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We declare the 10 ins. Then we can print out 10 ins like this. Stream ins nl. nl is new line console out. This command we build once again with GNU compiler. Okay, 1, 2, 3, 4, 5, 10 is displayed like this. Now Microsoft compiler like this. Now I will create another type using names t std string using names using I will say using name t, and I say names t std vector name t like this. Then names t names. Then I define Thomas Kim, Stephen Park, Sophie Turner, Demi Moore. So I declared a class, a vector of names t. Then we can display like this, stream names nl. Now let's build once again. Okay, Microsoft compiler works like this. We can actually create arbitrary names. I will define another type using age t int, using weight t double, using person t std tuple. A person has name t, name t. A person has age t. A person has weight t. Like this. We can define a tuple class like this. Then we can define people. ple, people t, std, vector, person t. So we can declare people like this. ple, people t, students, like this. Please note that this is a vector of a tuple person, so we have to provide name, age, weight, 3 items, 3 data member. Thomas, Kim, 19, 56 kilograms, 1 person. I define another one. It should be Steve Lee or James Dean. So I defined the 3 container elements. He is 18 and James Dean is 50 and 70 kilograms. Stephen Lee is 40 kilograms. No, 80 kilograms. Like this, we defined a vector of a class students. Then we can print out like this: string students NL, or we can say my students. Now let's build. Okay, Microsoft compiler works. My student Kim, 19, blah blah blah. Now GNU compiler. Okay, GNU compiler works. Now we will define array, int array. I will define 5 elements, 1, 2, 3, 4, 5 elements of integer array. Then we can print out like this: int array. Now we can print out like this: arr array nl. So this is single one-dimensional array with the Microsoft compiler. Okay, array is displayed like this. GNU compiler. Okay, it works. And we use tuple here. Now we want to use variant like this, using items, item t, std variant. Okay, we can hold name t, age t, weight t. We defined a variant type. It is called item. Name is string. We defined the name here. And age is int. Weight is double. Okay. Now we can define like this, using back t, std. You can put anything any container class such as std deque, std deque, then item t, okay, back t my back. Okay, my back contains elements. One of the elements string, int or double, like this. The good man. This is a book title. I have something called 20, or I have 56, or I have another book, The Future of C++, and I have another book title, The Best C++ Tutor, and we have something more, for example 67 or 30 integer. Now we can display contents of my book. Stream. In my bag, there are items as below. My bag NL. Okay, now let's build GNU compiler. Okay, the good man. In my bag, there are items as below: the good man, 20, 50, the future of C++, the best C++ tutor, blah blah something. Also now Microsoft compiler. Like this. We can define arbitrary array, for example double D array. Now we define two-dimensional double array like this. 3. We are defining two-dimensional array. 3.0 to, I will just say int. Okay. This is two-dimensional integer array. Now I will copy it multiple times. Once, twice, fourth. Now I will modify the values. 4, 6, 5, 6. So this is arbitrary integer array. How can I say? Two-dimensional array. Then we can print out like this. DALL array. Now we can print out like this, DALL array. Okay, it works. So we can define arbitrary container class and arbitrary advanced C++ constructs, all we can intermix together, and this string library, string class, helps us to understand how to develop, how to use advanced C++ constructs in our future development. Using this library, this type library, we can find out each element of data type. For example, auto, RA 5.6. Then we can find out type library, type name, like this. Type name of RA. Talk, play, fun. Get type category. We can provide RA and L. Okay. Then it gives us correct type name, type category of RA, like this. So type name of array is double R value reference. I created this type library to help my audience learn advanced C++ language. Please subscribe to my YouTube channel. I am looking forward to seeing you in my next video. Thank you for watching.